exterior angles and the more difficult diagrams that deal with triangles. So I just wanted to go through a couple examples on this video so you get something to reference at home while you were studying. Let's just start with problem E because I think that one's the easier of some of the problems. You'll notice that we are looking for angle 1 in this problem, and angle 1 is considered an exterior angle. And we know it's an exterior angle because it's formed by the extension of one of the sides of the triangle, and we know that specifically the sum of our exterior angles, the value or the measure of our exterior angles equals the sum of our remote interior angles. And we basically know what our remote interior angles are when we look at our triangle and see that we have two other angles that are not lying right next to our exterior angle. So in this example, 99 and 30 would be considered our remote interior angles. So what we would do to find the measure of angle 1 is we would add 30 plus 99, and we get that the measure of angle 1 is 129 degrees. And even if you don't remember that exterior angles is the sum of the remote interior angles, one thing you could do is you could actually just solve for the third angle in this triangle. So I'm going to get rid of the notations I just drew. You could actually find the measure of that third angle, and that's going to be highlighted in red, so this little angle right here. And what you could do is you could say, okay, 99 plus 30 is 129. And then when you subtract 129 from 180, you get 51. And so you know that that angle in red is 51, but angle 1 is actually the supplementary pair to 51. So you would have to go backwards and basically undo what you just did and say, okay, 180 minus 51 is again 129, and that would be the measure of angle 1. So that's two ways we came at the answer of the value of angle 1. And problem B is very similar. So this problem B is very similar to problem E, except that we are finding both the measures of 4 and 3. And so remember that angle 3 is our exterior, and our exterior angle, the measure of our exterior angle, is just the sum of our two remote interior angles. So to find the measure of angle 3, we would add 62 plus 44. We would get 108. And then remember that angle 4 and 3, so the measure of angle 3 plus the measure of angle 4, those two angles are a linear pair, so we know that those two angles together would be supplementary. And so we would just find the measure of angle 4 by finding what's supplementary to 108. So the measure of angle 4 is going to be the supplementary pair of 108, so 180 minus 108 is 72. So 72 would be the measure of angle 4. Okay. All right. So those two examples illustrate easier problems when you're dealing with exterior angles, but what about down in G when we are dealing with some variables? In this problem, it only looks harder because you've got two different variables you're dealing with. But if you just take it step by step, you can actually find that it's not that difficult of a problem. So what I'm going to do is I'm going to highlight that 130. I'm going to highlight that in red. Remember that 130 is our exterior angle. And we just talked about how our exterior angle is just the sum of our two remote interior angles. So I'm going to highlight my remote interior angles 54 and 4y also in red because they go together. We know that 54 plus 4y will be equal to the measure of that exterior angle. So 130 equals 54 plus 4y. And now you just have a two-step algebraic equation to solve for. So again, you would subtract 54 from both sides, and you would get 130 minus 54 would be 76 equals 4y. And then 76 divided by 4 would be 1, carry the 3, be 19. So the value of y would be 19. And then to solve for x, and I will just highlight right here, we got x in here, and it's kind of covered, so that says 2x degrees. We know that, and underlined in green, right here we've got a linear pair. And so to solve for that second variable, x, we could set up an equation where we've got the red angle 130 degrees plus 2x equal 180, because right there we have a linear pair, and we know that a linear pair is going to be supplementary to each other. So what I would do is, I'll do this in green, 130 oops, it's off the page, 130 plus 2x equals 180. And you could have actually done this first if you forgot that, if you forgot this whole part about the exterior angles, but you could have done this first. It really actually doesn't matter. And then all you have here is just another equation to solve for. So you're going to subtract 130 from both sides, and you get 2x equals 50. And when you divide by 2 on both sides, you get that x equals 25. And just by setting up two different equations, you've found the values for variables x and y. Important to remember is that if you have two variables in a problem, you need two separate equations to solve for it. So it wouldn't be right to set up an equation like the one I'm going to set up in black. So if you were to set up one in black like 2x plus 4y plus 54 equals 180, that wouldn't be right, because you notice that you've got two separate variables in one equation, and you would need a system to solve for these two variables. So just remember that if you have two variables, or even three, you need at least that many equations to solve for that number of variables. So if you have one variable, you just need one equation. If you have two variables, you need at least two equations. If you have three variables, you need at least three equations. Okay. And so that actually wraps up the talk about exterior angles. And so I just wanted to direct your attention to problem A, because it seems like we're also having some difficulty with problems when we've got multiple variables and there's 3 or 4 steps. So let's direct our attention to problem A right here, and we need to find the values or the measures of angles A, B, and C. And so what I normally say is, in these problems, whenever you've got numbers and variables and multiple variables in these equations, try to isolate it piece by piece. And so you notice that right up here, we've actually got an example of vertical angles. And remember, vertical angles are just formed when you've got two intersecting lines. These two angles would be congruent to each other, and these two angles would be congruent to each other. But then don't forget that you've also got some linear pairs. So highlighted in blue, we have a linear pair, and highlighted in green, we have a linear pair. And we actually have two more linear pairs that are formed, highlighted in black. So basically, you just got a bunch of different pairs that are formed. So just remember that of the 4 angles that you've got, you've got various different pairs going on that you can deal with in setting up different equations. So you'll notice in the top left, you've got angle C and angle A. And angle A, you should immediately be saying this to yourself, but angle A makes a vertical angle with that 37-degree angle. So you know, without doing any kind of computation, that the measure of angle A is going to be 37 degrees. So you've actually already solved for a third of the problem. Measure of angle A is 37 degrees because they're vertical angles. You also know that this angle C is going to be linear pairs with angle A or with that 37-degree angle. So what you know is that angle C is going to be supplementary to 37. So to find angle C, all you would do is you would subtract 37 degrees from 180. So when you do that, you get that the measure of angle C is 143. So now we've actually got 2/3 of the problem with doing very little math, and the math we have done has been pretty easy. Now to find angle B, we just have to remember that all three of our angles in a triangle sum to 180. And we already know that one of the angles measures 109 degrees. We have that already given to us in the problem. And we just figured out very easily that the measure of angle A is 37. So what we're going to do is we're going to say that, and I'll do this over on the right, that 37 degrees plus 109 degrees plus the measure of angle B equals 180 degrees. And now all we have is an equation we need to solve for, and all we need to use is just some simple addition and subtraction. So when we combine our like terms on the left, we get that 109 plus 37 is 148. 148 plus the measure of angle B is 180. And then we just need to subtract 148 from both sides. And we get that the measure of angle B is 32 degrees. So we have only used two equations and we've solved for all three of those angles. And then slightly more difficult, we have the bottom in problem C. So we're working with problem C now. We need to find the measure of angles X, Y, and Z. And this problem is not any more challenging, but you do have to just recognize that you've got various angle pairs. So down here, we'll start with 130. And you notice that 130 is that exterior angle. So remember that that exterior angle is going to be the sum of your two remote interior angles. And your two remote interior angles in this case are going to be 63 and x. So you can set up an equation, 130 plus, 130 equals 63 plus x. And then all you have to do is subtract 63 from both sides. And you get that x is equal to 130 minus 63 is 67. So we've already found for one angle. And then you'll notice that, and again, your eyes should start to be pretty quick to see this, but you've got vertical angles in the center. And so the value of y, so y and 63 are going to be congruent to each other. So y, without doing any math, has to be 63 degrees. So we've already found two angles very quickly. And lastly, we need to find this angle z. And we already see that we've got two of the angles in that triangle. And so you know that when you have two angles in a triangle, you can always find that missing third angle by just subtracting the two known angles from 180. So what I'm going to do is I'm going to take 85, add it to 63, because we know that's the value of y, plus z equals 180. And when I combine like terms, I get that 63 plus 85 is 148 plus z, 180. And then you just have to subtract 148 from both sides. And again, you get that z is 32 degrees. So again, using two equations that really didn't involve